Lesson number 2, Error Analysis. Whenever an experiment is performed, two kinds of errors can appear in the measured quantity. Number 1, indeterminate errors. Number 2, determinate, or systematic, errors. Indeterminate errors. Indeterminate errors appear randomly because of fluctuations in external conditions and variability of measuring instruments. The effect of indeterminate error can be somewhat reduced by taking the average of measured values. Indeterminate errors have no fixed sign or size. Determinate errors. Determinate errors occur due to error in the procedure, or miscalibration of the instrument. Such errors have same size and sign for all the measurements. These errors can be determined. A measurement with relatively small indeterminate error is said to have high precision, while a measurement with small indeterminate error and small determinate error is said to have high accuracy. The experimental error can be expressed in the following standard way. Error limits, Q, plus minus delta Q, is the measured quantity, and delta Q, is the magnitude of its limit of error. This expresses the experimenter's judgment that the true value of Q lies between Q minus delta Q, and Q plus delta Q. This entire interval, within which the measurement lies, is called the range of error. Indeterminate errors are expressed in this form. Absolute error. Error may be expressed as absolute measures, giving the size of the error in a quantity, in the same units as the quantity itself. Thus, absolute error of measurement is the magnitude of the difference between the value of the quantity and the individual measurement value. Relative or fractional error. Error may be expressed as relative measures, giving the ratio of the quantity's error to the quantity itself. In general, relative error is equal to the absolute error in a measurement, by the size of the measurement. We should know the error in the measurement, because these errors propagate through the calculations, to produce errors in results. Determinate error. They have a known sign. Suppose that a result R is calculated from the sum of two measured quantities, A and B. We'll use small a and b to represent the error in A and B respectively. Small r is the error in the result R. Then, capital R plus small r is equal to capital A plus capital B, plus small a plus small b. The error in R is therefore small a plus small b. Similarly, when two quantities are subtracted, the determinate errors also get subtracted. Suppose that a result R is calculated by multiplying two measured quantities, A and B. Then R is equal to A times B. Calculating, we get the relative error as the sum of the relative error of A and B. When two quantities are divided, the relative determinate error of the quotient is the relative determinate error of the numerator, minus the relative determinate error of the denominator. When a quantity Q is raised to a power P, the relative determinate error in the result is P times the relative determinate error in Q. Indeterminate error. They have unknown sign. Hence, they are represented in the form A plus minus small a. Here we are only concerned with limits of error. We must assume a worst-case combination, such that our measurement is accurate within that limit. In the case of subtraction, the worst case deviation of the answer occurs when the errors are either plus A and minus B, or minus A and plus B. In either case, the maximum error will be A plus B. The absolute indeterminate errors, add. The relative indeterminate errors also, add. If Q is raised to a power P, then the relative error in the result is P times the relative error in Q. Thank you. Visit physicsinbrief.com for assignments, mock tests and more courses.